Welcome. We are here at the 2013 Solar Decathlon. My name is Adam Plesniak. I am the Director of R&D at a company nearby here in Seal Beach named Amonix. We do CPV photovoltaic systems. I'm also a chair for SPIE Optics and Photonics for the Solar High and Low Concentrator Conference that happens annually down in San Diego. And we're here today at the Solar Decathlon. This is an event that's held biannually by the Department of Energy, started in 2002. There are 19 homes here in the great and sunny city of Irvine, California, at the Great Park here, and this is actually the first time this event has been held outside of Washington, D.C.
There's a lot that goes into the engineering that doesn't necessarily show up in the actual homes that people are touring during this event over the 2-week period. The engineering jury starts with a review of the engineering analysis that each team goes through, and that engineering analysis includes the photometrics of the lighting in the house, how much solar is going to be created based on the angles they're going to use their solar collection for both solar photovoltaics for electricity and solar thermal for heating hot water that's in the homes themselves. They analyze on an annual basis how much energy the homes will actually consume and then try and balance that out with the on-site renewable energy that's in the house in order to make sure that this house ends up being net zero energy on an annual basis.
We actually offer 3 separate solar systems on this house. If you can see on that front overhang over the south-facing windows, we have a bifacial array, and those are bifacial panels with monocrystalline cells on the top and amorphous cells on the bottom. So the top generates in direct sunlight and the bottom can gather ambient light and can add to the solar generation of those panels. We also have our flat plate solar thermal collectors on top of the solarium here that can generate all the hot water that we need in our domestic system and in the radiant floor loop. We also have the 10K solar wave PV system, and that's a specially designed PV system for flat roofs. And it's all gravity ballasted, held on to the roof by nothing more than gravity. And it's a really specific flat roof application with reflectors on the back and collectors on the front of each wave. And those reflectors can actually focus more usable light onto the panels, making their efficiency much better.
So we worked tirelessly on this building envelope over 3 years, trying to perfect how we can integrate vacuum insulation panels, which you see here is an emerging technology in the construction industry. Currently, this vacuum insulation panel is used in refrigerators and microwaves by Panasonic. So our team developed a wall system in partner with Algonquin College, who is a trade school. We had an advanced housing construction carpentry program, so we got the opportunity to work with real carpenters to enable us to come up with a practical design with sound engineering and innovative materials. So our overall wall system, we built a test study in Carleton University and exposed it to winter conditions in Ottawa, and we published a paper on this wall assembly to give us an effective R value of R53. This is over twice the R value of a Canadian home built in Ontario.
Welcome here to, this is the Middlebury College house, and this house has a couple really cool features, one of which you can kind of see, which is the bifacial solar cells. So these are solar panels that are effectively, the material used to hold the cells is transparent. So it gives it kind of a more architectural feel than just kind of an aluminum framed, plastic backed solar panel. So they've used it here as an architectural feature, and I personally think it looks really good. A couple other things about this house is the reclaimed wood they've used for the siding. Gives it a really nice rustic feeling. You don't feel like you're in some kind of house of the future. Really nice feature there. They also have a green roof, so they grow plants, stuff like that on the roof, and that's good for a number of features. It's great insulation, and yeah, all in all, a beautiful house. We are standing here in front of the entry from the Czech Republic. This house won the Architecture Award this year, and it's got a couple interesting features that are worth mentioning. Most obvious is the slatted design here on this exterior skin. And basically, if you talk to some of the students who built this house, they took their inspiration from a type of architecture that was used on old Czech cottages in the country.
So air house energy concept is based on what we call house within house concept. We work with two skins, with the thermal insulated envelope of the living area and with a wooden shading canopy which protects the home from thermal stress. But of course, the house couldn't be energy self-sufficient without our technology. So the canopy holds our 33 monocrystalline PV panels and two flat solar collectors, which we use for preparation of hot water, and we also use it for our radiant ceiling.
Right here we have a solar water preheater. We have a solar collector on the roof, pipes down into this barrel, makes a hot water bath for phase change material. It's a wax-like composition. It holds heat 50 times better than traditional just water-based systems. It preheats the water in our traditional domestic water heater. We can get temperatures about 125 degrees, 120 degrees with no electric heat. This here is our control systems box. This was a student project, all undergraduate. We built and programmed this box. It controls everything in the house, including our lights, our motorized windows and doors, our motorized blinds, and it can also control the temperature of the house depending on the user's specifications. We have an Android app currently that's running on a tablet inside the house, so a user can control it from anywhere they have internet access.
We just got a chance to see the Santa Clara house, and right outside the Santa Clara house you can see we've got a number of electrical boxes and electrical spaghetti here. And it's an interesting topic of discussion right now in the industry is a lot of people are starting to do this with their homes. They're starting to put solar on their homes. They're starting to collect their own energy from their rooftop with solar panels and use it in their home. And one of the big challenges for us as a country, and in fact the world, is how do you transition from a completely utility-based model for power generation where power is made at one or a couple of places and then sent out to users to where the users are generating their own energy? This is the big question of basically smart grid. When you hear the word smart grid, it's how do you integrate all of this into a system that works effectively, seamlessly, and to the benefit of everyone involved. Really state-of-the-art stuff here in all of these homes. All of the students have done a fantastic job, and I think everyone that's been here is eager to see what's going to happen 2 years from now at the 2015 event.